How are you, my friends? This is Pre-Calculus course lecture 39, the one before the last lecture. The last one is lecture number 40. This is hyperbolas as a conic sections. So in this lecture, we have 4 ideas in the objectives. We will define the hyperbola. We will look at the equation and the graphs, shifted hyperbolas, and finding the eccentricity. What is a hyperbola? A hyperbola, as the other graphs, is set of all points xy in a plane such that the absolute value of the difference of the distances from two fixed points is constant. I know it's not easy, but I will go and explain it. This hyperbola, this is two pieces of the graphs. Each point on the hyperbola, each point here like P, X, Y, the distance from P to the first focus, F prime, minus, that's the difference here. See the difference? Minus the distance from P to F is equal to A. That's the constant. Now what is A? A vertex here, the first vertex is VA0. There is another vertex V prime minus A0. So there are two vertices for the hyperbola. There are two foci. F C0 is inside, and the other one is F minus C0. Center is the midpoint of the line segment, F prime, also the midpoint of the line segment, V prime. Now, let's, later I will explain asymptotes in a few minutes. Transverse axis is the line segment VV prime. So this one we call it transverse axis. So here we have 0 to A, and here we have minus A to 0. So we can draw here a rectangle. And if we draw here 0B, 0 minus B, I will explain in the next slide what is 0B, 0 minus B. We can generate a rectangle, we call it fundamental rectangle. This side is 2A, this side is 2B, so the area will be 4AB. Some books, they call it central box. This is the same meaning of fundamental rectangle. Let's go more in deep. To derive the equation, we take, as I mentioned, take any point P. Again, we say that P F prime, see the distance, minus PF. So use the distance formula, is equal to A. Square both sides, you have to proceed there until you reach this equation. Now, in the middle, we use C squared is equal A squared plus B squared for the hyperbola. Remember in the ellipse, in the previous lecture, we had C squared is equal A squared minus B squared. So in the hyperbola, A can be equal to B, or A less than B, or A greater than B. So we have x squared over A squared minus y squared over B squared is equal to 1. The A squared under the positive, see A squared always under the positive. If this positive is x squared, this is a horizontal transverse axis like this. If the positive under the y squared, as we will see in the next slide, I will show it to you now. See here we have y squared over A squared. It will be a vertical transverse axis. So we have to remember the equation of the hyperbola. There is a minus in the middle here. This is the standard form. X squared over A squared minus y squared over B squared is equal to 1. Transverse axis is horizontal. This is from V to V prime. This is, we call it conjugate axis, the endpoints of the conjugate axis, where we have 0B, 0 minus B. The red dots are the foci, C0 there, and minus C0. Now, the same thing here, but the equation has y squared over A squared minus x squared over B squared is equal to 1. So the only difference is we have a vertical transverse axis. So the vertices 0A, you can see on the y-axis here, 0A, 0 minus A. The conjugate is B0 minus B0. And the foci also, they are inside the hyperbola 0C, 0 minus C. Now, every hyperbola has a fundamental rectangle here. If you take the diagonal, the first diagonal, you draw a line, dashed line, that will be the first asymptote. If you take the other diagonal and you draw a line, it will be the second asymptote. Here is a quick way for finding asymptotes of the hyperbola. Before I do that, I will explain the idea of the asymptotes. Suppose we have a hyperbola equation like this: x squared over a squared minus y squared over b squared is equal to 1. Let's solve for y, which means let's see what will happen to the graph as x goes to infinity in both directions. So let's solve for y. Take this on the other side, x squared over a squared minus 1. Here we add on the right side x squared minus a squared over a squared. Multiply by b squared, I get y squared is equal to that. Take the square root of both sides, y will be plus or minus b over a, the square root of x squared minus a squared. Remember, a squared is a fixed number, so it can be 7, 19, 50, 49, any number. X is variable, you see? So a is fixed, x is variable. As absolute value of x increases, that means we can go in the positive x or in the negative x. What will happen to y? If absolute value of x increases without bound, goes to infinity, then x squared minus a squared is approximately x squared, because we are subtracting a little constant from a variable that goes to infinity. So we can have here, instead of all this, approximately x squared. Now, the square root of x squared will be the absolute value of x, since we have plus or minus. So y will be plus or minus b over ax. So that will be the equation of the asymptotes. Now, this is a long process to find it. Very quick, easy way to find the asymptotes. Replace 1 by 0. So this is the equation here. Replace 1 by 0, and then y will be plus or minus b over ax. You solve for y. 2 steps easily you can use anytime you need to find the asymptotes of any hyperbola. Now, sketching, we start with the central box, which is fundamental rectangle. We put plus or minus a, plus or minus b. We sketch the asymptotes, the 2 diagonals, we join them, dashed lines. Then we put the vertices. Then we draw the hyperbola. Let's see a nice easy example first. Part A, find the coordinates of the vertices and the foci of the hyperbola x squared over 25 minus y squared over 49 is equal to 1. This equation is ready. The positive here is x squared, right? There's a negative here with the y squared. So the positive here under the x will be a squared. So directly we take a squared 25, b squared 49. So we can draw 5, 7, 5 minus 7, minus 5, 7, minus 5, minus 7. We can draw we call them the 4 corners of the fundamental rectangle or the central box. We can draw these 4 corners. Then we join the diagonals. We have the asymptotes. The vertices will be 5, 0 here, minus 5, 0. And the foci are inside. Use the formula c squared is equal a squared plus b squared. The first focus will be square root of 74, 0 on this side. And then on this side, it will be minus square root of 74, 0. These are the asymptotes. Replace 1 by 0. Solve for y. This is the domain from minus infinity to minus 5. 5 close to infinity, and the range is all real numbers. Now, if you look at this example, y equals minus 5 square root of x squared plus 16 divided by 4. We can imagine or expect this will be half of something, probably hyperbola. So to know the basic graph, we square both sides. See, this will be y squared, the minus will disappear. This is 16, 25, and this we remove the square root. Rearrange it. Y squared over 25 is equal to x squared plus 16 over 16. Rearrange it more and more until you get y squared over 25 minus x squared over 16 is equal to 1. See, this one has no x-intercept, only y-intercept plus or minus 5. This one here, you can see this one is a complete hyperbola. But what do we have here? Y equals minus, and all this is plus, positive. So y is negative. So what can we do? We draw half of the hyperbola where the y is negative. Now the domain is all real numbers, and the range only from minus infinity until minus 5 closed. So this graph is half hyperbola. Find an equation for the hyperbola having foci 0, 5 and 0, minus 5, and the equation of asymptotes, both of them, y plus or minus 3 over 4x. So we can start by a little sketch. If I put here 0, 5, it will be on the y-axis, and 0, minus 5 also on the y-axis. So this is f1, f2, or f prime. And the asymptotes are y equals plus or minus 3 over 4x. So we can imagine the graph will look like this, because the foci are inside the hyperbola. The asymptotes are y equals plus or minus 3 over 4x. I put here in this box, I said the hyperbola has a vertical transverse axis because of the foci, and also the equation, it will look like y squared over a squared minus x squared over b squared is equal to 1. And here the center 0, 0. So there is no shifting. So the equation of the asymptotes, if you put y here, replace 1 by 0, solve for y, you will get this one. You compare with the given, just compare it, y equals plus or minus a over bx, and this is the given. So directly we can say a3 and b4, square it, write the equation. Now let's look at the shifted hyperbolas with center hk. If the transverse axis is horizontal, then this is the standard form. The same as the one with center 0, 0, but we have here h and k. So it will be x minus h squared over a squared minus y minus k squared over b squared is equal to 1. Still the a squared under the positive, so we have the center hk. The vertices, it was plus or minus a 0, so we add h to the x, we add k to the y, and also the foci, it was plus or minus c 0 for this hyperbola. So we add h to the x and k to the y, and always for the hyperbolas we use c squared is equal to a squared plus b squared. Remember asymptotes? Instead of memorizing all this, what can you do? Replace 1 by 0, solve for y. Replace 1 by 0, solve for y. The second type, we have a vertical transverse axis. So we have y minus k squared over a squared minus x minus h squared over b squared is equal to 1. The asymptotes we know. It was, the vertices was 0, a, 0, minus a. We add h to the x, we add k to the y. Same thing for the foci, and the same formula for finding c. Let's see this example. Graph the hyperbola. Example 4. Find the coordinates of the vertices and the foci, and find the domain and range. Now in the solution, we need to rearrange the equation. So we take 9y minus 1 squared on the other side, and then we divide by 36. We reach here the standard form, x plus 1 squared over 9 minus y minus 1 squared over 4 is equal to 1. So the center is very clear here, minus 1 and 1, and the transverse axis is horizontal. So a squared is under the positive here. See the positive here, x plus 1 squared. So a squared is 9, a plus or minus 3, b squared is 4, and b plus or minus 2. So on the next slide, we see how to find the vertices and the foci. So we can use now a squared is 9 and b squared is 4. So the vertices, just write the formulas. V, a plus h 0 plus k minus a plus h0 plus k. You will find the first vertex to 1, the second vertex minus 4, 1. Now for the foci, we use the formula c squared is equal to a squared plus b squared. So c will be plus or minus square root of 13. Put the formula for the foci and find the answer. On the next slide, we see these 4 points are the corners of the fundamental rectangle. Minus 4, 3, 2, 3, minus 4, minus 1, 2, and minus 1. So we start here. From the center, we go right and left, 3, up and down, 2. So we have to find the asymptotes, replace 1 by 0, solve for y. Now the domain will be minus infinity to minus 4. See this point here, union 2 to infinity, and the range is all real numbers. Now let's define the eccentricity as we did in the ellipse. So E will be C over A. C, the distance from center to the focus, and A is the distance from the center to the vertex. In the hyperbolas, E greater than 1. Narrow hyperbolas, they have E near 1, like 1.1, 1.2, 1.5, whatever. Wide hyperbolas have large E. So it can be any number greater than 1. Important question here. Find an equation for the hyperbola with eccentricity 2, foci minus 9.5, minus 3.5. Nice idea to sketch minus 9.5, minus 3.5. We know these are the vertices, so we know the hyperbola is like this. So the foci, as I said, minus 3.5, minus 9.5, and the eccentricity is 2. So the transverse axis is horizontal, since foci lie on this axis. So we find the center is the midpoint of f prime. Use the midpoint formula, x1 plus x2 over 2, y1 plus y2 over 2. So the center hk will be minus 6 and 5. Now c is the distance from the center to any focus. So c will be absolute value of a minus b, minus 9 minus minus 6. It will be 3, so c squared will be 9. So from the last slide, we see that c squared is 9, so c will be 3, and the eccentricity equals 2 is given. We go to eccentricity formula, E equals c over a. 2 is E, c is equal to 3. We put a there, so a 3 over 2. Square it, a squared is 9 over 4. So we can find from there c squared is equal to a squared plus b squared. C squared is 9, 9 over 4. We find b squared 27 over 4. So we can write the equation now. Remember the center is minus 6 and 5. So x plus 6 squared over 9 over 4 minus y minus 5 squared over 27 over 4 is equal to 1. We have to rearrange it. This is a good answer here. We can leave it. Or we can write it 4 times x plus 6 squared over 9 minus 4 y minus 5 squared over 27 is equal to 1. Either equation will work. Now, this is lecture 39, the hyperbolas, conic sections. At the end of lecture number 40, which is the end of this course, pre-calculus course, lecture number 40 will be general equations of shifted conics. After lecture 40, these are related, 39 and 40. So you can find some old exams questions to practice on both lectures. Thank you for watching. If you like the video, you can subscribe and share it with your friends. Just to remind you, this is pre-calculus course, lecture number 39, the one before the last lecture in the course. I hope I can see you in another video with another topic. Thank you guys for listening.